Alright, so in this video, we're going to evaluate the integral of sine squared of x dx. So how do you suppose we evaluate this integral? Well, one way that we can do it is we could use the identity for cosine of 2x. If we recall, cosine of 2x is equal to this. Now, we can replace cosine squared of x with 1 minus sine squared of x, because that's true by the Pythagorean identity, right? If you recall, this would also be a true statement. Since cosine squared of x is equal to 1 minus sine squared of x, we can replace cosine squared of x with 1 minus sine squared of x. So that's what we're going to do. So as you can see, we replaced cosine squared of x with 1 minus sine squared of x. But really, this is 1 minus sine squared x minus sine squared x. This is overall 1 minus 2 sine squared x. Because all we're doing is combining like terms. Now, what we're going to do at this point is we are going to algebraically solve for sine squared of x. And to do that, what I'm going to first do is I'm going to subtract 1 on both sides. This leaves us with cosine of 2x minus 1. And this leaves us with negative 2 sine squared of x. Next, I can divide negative 2 on both sides. Overall, I can split the left side up into 2 fractions, like this. And on the right side, this is just sine squared of x. This first term is just negative 1/2 cosine of 2x. And for our second term, the two negatives join forces to make a positive. So this is what we get. Now I can flip this around to saying 1/2 minus 1/2 cosine of 2x. And I can factor out a 1/2 from both of these terms. So this is what sine squared of x is equal to. And most people tell you to memorize it, and I recommend doing that too because memorizing things are fun, right? That was good. So you'll tend to use this a lot when you're evaluating sine and cosine integrals with even powers. So yeah, we're going to use this identity to solve this integral. So we can replace sine squared of x with what we have here. Because 1/2 is a constant, we can pull that to the outside of the integral. And so as you can see, we can split this up into 2 integrals. We have the integral of 1 minus the integral of cosine of 2x. Now the integral of 1 dx is just x. And as for the integral of cosine of 2x, this is going to be 1/2 sine of 2x. And overall, we'll have a plus c. I can distribute the 1/2 across. And so this would be our final answer. And so, yeah, that is one way that we could evaluate the integral of sine squared of x. Just by using this identity, which we could derive, right? I like that word, derive, right? That was good. So yeah, that's pretty much it for this video.